Hello and good day. My name is Zelafy Reynosa, and I'll be presenting about my research proposal with the title Biomechanical of Three-Dimensional Printed Invisible Liner for Orthodontic Problems. So there will be 6 parts to my presentation. The first chapter is the introduction. So for the background of study, the development of dental aligners are more preferable than the conventional braces, especially to treat misaligned teeth for adults. And these aligners are changed every 2 weeks and they are worn for about 20 hours a day. The teeth will move around 0.25 to 0.3 millimeters with each aligner. Even though there has been past studies on the clear aligner, there is still a lack of information about the factors that make dental aligners more fit and comfortable for the patient's mouth compared to the conventional braces. The second one is the issues with the accuracy of the printing orientation and its mechanical strength. And the third one is the layer height. It affects the time it takes for the printer to finish, and also it affects the printing accuracy. There are going to be 3 objectives in this research. The first one is to design 3-dimensional dental aligners with different layer thicknesses. And the second one is to 3D print dental aligners with different printing orientation angles using an SLA 3D printer. And the last one is to biomechanical analyze a 3-dimensional printed invisible liner with different layer thicknesses and print orientation angles. For the scope of study, the first one is the software modeling. So the aligners with 7 printing orientation and 5 layer thicknesses will be designed using thematics and mimics. Second one is the fabrication of clear aligner. So we will be using an SLA printer to print this clear aligner. The third one is the mechanical strength. The mechanical strength will be evaluated by applying compression load using an instrument machine. And the last one is the UV light treatment. The dental liner will be cured to allow the resin to fully firm and provide the greatest mechanical qualities. For the significance of study, the first one is to produce a clear aligner that is not only biocompatible, but it can withstand excessive mastication and biting force when the patients are using it. The second one is to improve the manufacturing process, optimize print settings, and improve overall aligner quality. For chapter 2, it is the literature review. So there are 6 different types of misaligned teeth. We have the underbite, overbite, crossbite, crowded, gap teeth, and open bite. All these types of misaligned teeth can be treated by clear aligner therapy, but the most common ones are overbite and gap teeth. So the clear aligner therapy, the aligners, they function by exerting a light pressure on the teeth to gradually reposition them to its new position and its socket. So it takes time for the tooth to move. So that is why it is recommended that the patients use the same aligner set for about 7 to 10 days. So next, there are 2 different types of manufacturing of clear aligner. The first one is thermoform. This is a traditional method of producing an aligner, and it involves taking a dental impression from the patient. So there will be a resin here, and it will be put into a mold, and then it will be vacuumed with the thermoforming equipment, and the excess will be trimmed, like this picture here. Second one is the 3D printed. It constructs the object layer by layer by depositing material according to desired shape. This is an example. By past studies, 3D printing has been proven to have a reduced process time and also lower prices. Next, we have is the different designs of the aligner. There was a past study that used different designs with different thicknesses, and it is proven that the direction and extent of tooth movement are determined by the shape of the aligner split. There were 4 different types. The first one is the scalloped, and the second one is the scallop extended. The third one is the straight, and the last one was the straight extended. At the end, it was proven that the straight exerted more force than the scalloped one. Post-curing is a process involving heat and light to reinforce and stabilize the 3D printing materials. And this technique can also maximize the material's physical attributes and mechanical properties. For chapter 3, I'll be talking about the flow chart and also the methodology. So for the flow chart, I have included everything from the problem identification up until the findings of my data analysis and comparison. Next, that is the methodology. So first we have the digital image acquisition. Actually, we already have the patient data because we have worked with 3D gens. Next is the software modeling. So for the software modeling, I'll be using Mimics and 3matic software to design 5-layer thicknesses. And for the 3D printing, we'll be using an SLE printer to print 7 different build angles. And after the printing, the dental liners will undergo post-curing treatment for 20 minutes in 80 degrees Celsius. Next, for the mechanical testing, we will test all the dental liners under compression loading by using the instrument machine. And for the effectiveness of UV light, the liners will be separated into 2 groups to test the effectiveness of UV light. One group will be the control testing, so they will not undergo UV light, and the other group will undergo UV light. And this will also be evaluated by compression loading using instrument machine. For chapter 4, it is the expected result. So we will print dental liners with 5-layer thicknesses and 7 printing orientation using an SLE printer. So for the first picture, this is what we expect to achieve when the 3D printed aligners, they have been cured, but they still have the support structure. And the second picture is what we expect to get when we remove the support structure. This is the expected results when the dental liners undergo the compression molding by the insert machine. So this one is the expected results for the building angle with a 15-degree interval. And the second one is the one for the layer height with a 20 micrometer interval. And for the third one is the expected results for the UV light curing. So the group that will undergo the UV light curing at 80 degrees Celsius for 20 minutes are expected to have better mechanical properties than the control group. And the cured one is expected to reach a maximum load of around 662 Newton. In conclusion, the aim of the study is to produce a clear aligner by using dental LTO with a specific value for the layer height and building angles. I hope that the study will improve the accuracy and mechanical properties of the current dental aligner. I aim to meet all the objectives and also obtain the predicted outcomes at the end of this research. That is it for my presentation. Thank you for listening.